This program is an introduction on how to use and read the outside and depth micrometers. Part 1 is on the outside micrometer, followed by Part 2 on the depth micrometer. The gauge presented in this part of the program is the outside micrometer, also called simply a mic. The standard 1-inch micrometer is used to measure the distance between the outside edges of a part. The micrometer is the most commonly used precision instrument throughout industry. Micrometers are used to measure accurately to 1/1000th of an inch. The micrometer is used by inspectors and machine operators to measure raw materials as well as piece parts manufactured at Honeywell. Every part is made from a blueprint and is designed to perform a specific function. The micrometer measures the part to be sure it meets the specification of the print. Let's examine the micrometer now to name each part and explain its function. The frame of the micrometer is the part that looks like a horseshoe. It curves around the object being measured and has the size of the micrometer printed on it. The spindle of the micrometer is the part that moves in and out as an object is being measured. The anvils are the surfaces that come in contact with the part being measured. One anvil is located on the end of the spindle. The other anvil is directly across the frame. The contact surfaces are flat and parallel and are made of carbide steel and then polished to a smooth, shiny finish. There is a lever lock located on the frame of this micrometer and is used to lock the reading in position. The sleeve of the micrometer has markings printed on a 1-inch scale. The thimble is turned to adjust the micrometer for different measurements. Micrometer measurements are calculated by reading the sleeve and thimble scales. This mic has a ratchet stop. It will automatically slip when too much pressure is exerted on the part. Not all micrometers have a ratchet stop. There are different sizes of outside micrometers. The standard 1-inch mic measures a distance between 0 and 1 inch. A 2-inch mic measures only the distance between 1 and 2 inches. A 3-inch mic measures from 2 to 3 inches, and so on. All measure to the nearest 1/1000th of an inch. It's very important to use the correct size mic for every part being gauged. The size of each mic is printed on the frame. The sleeves and thimbles on the different sized mics look and measure exactly the same. You have to remember what size mic you're using and add that dimension to your reading. Micrometers should be cared for properly and not used as a C-clamp, vise, or anything other than what it is designed for. Use common sense. Don't place it where it could easily be knocked on the floor or in a pocket where it could fall out when bending over or reaching for something. There are many dirty elements in a factory environment that the micrometer should be protected from, such as abrasive dust, filings, and dirty oil. It makes sense to keep such a delicate instrument as clean as possible. Check the anvil contact faces to make sure they are flat and free of nicks or dirt. Dirt can produce inaccurate readings. The anvils should be cleaned before any gauging starts and any time you think they have picked up some dirt or oil. To clean the anvils, put a clean piece of paper between them. Lightly close the anvils down to hold the paper, but not too tight. Pull the paper through the anvils. Open the mic back up before the edge of the paper reaches the anvils and remove the paper. Don't pull the edge of the paper through the closed anvils. Oily parts being gauged should be wiped dry with a clean shop cloth before contacting the anvils. Oil on the anvils will actually pick up dirt. The slightest buildup of oil and dirt will produce inaccurate readings. Burrs will also produce inaccurate readings. Be careful not to gauge a part over a burr. When finished using a micrometer or in between parts, be sure to lay it down on a clean shop cloth to keep it free from dirt. There are specific micrometers designed for specific areas the standard outside micrometer cannot gauge accurately. These micrometers are read the same as the standard outside micrometer, but are designed with special features. The blade mic and flange mic are two common examples. The blade mic is used to measure very small, narrow areas on a part where the outside micrometer cannot reach due to the size of the anvils. Narrow undercuts, slots, and notches on a part can be easily gauged with a blade mic. Be very careful not to exert excessive pressure. This mic can be easily damaged if not using a light touch. The anvils on a flange mic are very wide and thin to get into small areas. This special micrometer can be used to measure several features of a part. It's commonly used to check the thickness of a flange or the length to an undercut. The outside micrometer is made to be held in the right hand. The markings on the sleeve and thimble can be easily read this way. The frame of the micrometer should rest in the palm of the hand with 1 or 2 fingers looped through the inside of the frame. The thumb and index finger turn the thimble to make reading changes. The part being gauged is placed between the anvils with the left hand. It's normal for the mic to feel awkward at first. After a period of time and with practice, the mic will feel natural in your hand. When making large reading changes, roll the thimble of the micrometer up or down the forearm. The micrometer has been calibrated precisely to take accurate measurements. To check the micrometer for accuracy, slowly turn the thimble down to 0, where the 0 marking on the thimble lines up with the horizontal marking on the sleeve. When you zero in a mic, be sure not to exert excessive pressure. You should develop a light touch. The correct pressure or correct feel for zeroing in comes with experience. Practice is important to develop a light touch. After the mic is zeroed in, check the anvil contact surfaces. The contact surfaces are flat and parallel and should match perfectly. The micrometer should be taken back to the gauge crib if there is a gap between the anvils or if the mic will not zero in. Never take a mic apart. The pressure used to gauge a part is the same amount of pressure used to zero in a micrometer. The part being measured should be snug but able to slide between the anvils. If the thimble sticks as you back it off, too much pressure was used and an inaccurate reading was obtained. When the reading is obtained, the thimble is backed off and the anvils opened to remove the part. Never pull the part out without opening the anvils first. When gauging a cylindrical part, the part must be checked once, rotated 90 degrees, and checked again to make sure it's round. It's also important to check the diameter at each end to make sure the part does not taper. Now that you know how to care for and handle a micrometer, let's see how the mic works and how to read the standard 1-inch mic. There is a 1-inch scale printed on the sleeve of the micrometer. The inch is divided into 10 equal spaces. These spaces are numbered from 1 to 10. Each numbered space is divided again into 4 equal segments. Each line equals 1/40th of an inch. But when reading a micrometer, measurements are read as decimals, not fractions. So 1/40th equals 25 thousandths of an inch. 1 revolution of the thimble equals 1 line on the sleeve. Every line on the sleeve is equal to 25 thousandths of an inch. A total of 4 revolutions of the thimble will bring it to the line numbered 1 on the sleeve. The number 1 is equal to 4 times 25 thousandths or 100 thousandths of an inch. 2 is equal to 200 thousandths and so on. The thimble also has a scale. The thimble scale is numbered from 0 to 25. Each line on the thimble equals 1/1000th of an inch. For example, let's read the measurements on this standard 1-inch micrometer. To read the micrometer, locate the highest number showing on the sleeve, the last complete vertical line showing on the sleeve, and the number on the thimble that matches the horizontal line on the sleeve. Then add them together to find the total reading. In this example, the 4 is the highest number showing on the sleeve. 4 equals 400 thousandths. Let's call this A. The thimble is turned beyond the 4 2 more vertical lines on the sleeve, each being equal to 25 thousandths. 2 times 25 thousandths equals 50 thousandths. Let's call this B. The marking on the thimble, which lines up with the horizontal line on the sleeve, is 8. The number 8 on the thimble is equal to 8 thousandths. Let's call this C. We must add the sleeve reading together with the thimble reading to obtain the total reading. Add A, B, and C. 400 thousandths plus 50 thousandths plus 8 thousandths equals 458 thousandths of an inch. Let's try another reading. Use a pencil and a piece of paper to follow along. Locate A, the highest number showing on the sleeve of this micrometer. It is 6. 6 equals 600 thousandths. Now locate B, the last complete vertical line showing on the sleeve. It is the second line after 6. Each line equals 25 thousandths, so the second line equals 50 thousandths. Locate C, the number on the thimble which matches the horizontal line on the sleeve. It is 3, which equals 3 thousandths. Now add all 3 findings together. $600 thousandths plus 50 thousandths plus 3 thousandths equals 653 thousandths of an inch. One more example before you try some readings on your own. Locate A, the highest number showing on the sleeve. In this example, 2 is the highest number, which equals 200 thousandths. Locate B, the last complete vertical line showing on the sleeve. It's the third line after 2. Each line being equal to 25 thousandths, the third line is equal to 75 thousandths. Now locate C, the number on the thimble which matches the horizontal line on the sleeve. It is 24. 24 on the thimble equals 24 thousandths. Now add A, B, and C to get the total reading. $200 thousandths plus 75 thousandths plus 24 thousandths equals 299 thousandths of an inch. Be sure to accurately read the micrometer. When a reading appears to be on a line, look closely at the thimble. If the thimble reading has not yet reached 0, the reading has not yet reached the complete line. The line for 3 on the sleeve in this example can be seen. However, the thimble has not completely reached the line. If you anticipate the reading to be at least 300 thousandths and add 24 thousandths from the thimble, the reading will be off 25 thousandths or 1 thimble revolution, which is one of the most common reading errors. We will now show you 3 separate mic readings to calculate on your own. Write down the readings you obtain on a piece of paper At the end of each reading, we will review it so you can determine whether you are reading the mic correctly. This is reading number 1. Please read the mic and calculate the answer before it is reviewed. On reading number 1, A equals the highest number showing on the sleeve, or 7. 7 equals 700 thousandths. B equals the last vertical line showing on the sleeve, or the third line after 7, which equals 75 thousandths. C equals the number on the thimble that matches the horizontal line on the sleeve, or 14, which equals 14 thousandths. 700 thousandths plus 75 thousandths plus 14 thousandths equals 789 thousandths of an inch. Your total reading for reading number 1 should be 789 thousandths of an inch. This is reading number 2. For reading number 2, A is 0, the highest number showing on the sleeve. B is 25 thousandths, the last complete vertical line showing after 0. And C is 15, the number on the thimble that matches the horizontal line on the sleeve, which equals 15 thousandths. As we add our readings together, A equals 0, B equals 25 thousandths, and C equals 15 thousandths. Your total reading for reading number 2 should be 40 thousandths of an inch. This is reading number 3. When reading the mic on number 3, A is 3, the highest number located on the sleeve. A equals 300 thousandths. There are no complete vertical lines showing after 3, so B equals 0. C is 18, the number on the thimble that matches the horizontal line on the sleeve. C equals 18 thousandths. Add the readings together. 300 thousandths plus 0 plus 18 thousandths. The total reading should be 318 thousandths of an inch. Now we will show you the final 3 micrometer readings and give you time to calculate them on your own before we confirm your answer. This is reading number 4. The total reading for reading number 4 is 420 thousandths of an inch. This is reading number 5. The total reading for reading number 5 is 597 thousandths of an inch. This is reading number 6. The total reading for reading number 6 is 384 thousandths of an inch. If you had trouble calculating these readings or you are not quite certain how to obtain them, please view this presentation again. And when you feel comfortable with reading the outside micrometer, take the written and performance tests. After successfully completing the tests, return to this tape to view Part 2 of this program on the depth micrometer.